problem in the second sheet. The next author about the paper ID 230, which title A Study on Designing School Curriculum for Grammar Material Based on the Numerical Simulation. Which author Tuấn Anh Bùi and Văn Thiên Trần.
Văn Thiên. Okay.
So hello, sorry, excuse me, can you hear me?
Yes. Yes.
So I just inquired that why we have the presentations at 10:15 news, new oceans, something like that, but we delay, right?
Oh no. Okay. Now, can you present now? In the paper ID 148, right? The title A New Ocean Wave Energy Adjustment Method using pendulum-spiral spin system, right?
Yeah. So I
Are you ready to present your presentation?
Yes. So can I check the presenter?
Yeah.
Can you give me permission to presenter?
Yes. Yes. You can begin.
Phạm Hữu Năng. Yes.
Yeah.
So I take the presenter now.
Yes. Yes, Mr. Phạm Hữu Năng.
Yes. So can you see my share screen?
Yes.
Okay. So I think you can hear me clearly.
Yeah, very clear.
Okay, thank you. Hello everyone, nice to meet you. I am Năng from Vietnamese German University, and I'm happy to share my topic, ocean wave energy converter using pendulum and spiral springs. Let's see how this assembly turns ocean waves into electricity. There are 5 parts that I want to talk in this topic, which are around the world before. Can we do it better? How does it work? How it is made? And conclusion. Now, let's see what have we done before. It has been 222 years since the first patent was granted to Monsieur Girard and his son. Really hard to see info of this event. Only a few short descriptions here. Until now, so many wave energy technology, as you can see here, and many wave energy devices have been tested, decommissioned, improved, and redeployed over the years, such as Pelamis 750 kilowatt, 20 million euro, and working in 4 years. Or the Dragon 7 megawatt, 14 million euro, working in 6 years. Or Seto 5 and Seto 6 from 200 to 1000 kilowatt, tens of millions of euro, and working in only 1 year. And Waystar, and so on. There are many wave energy companies had to shut down because of financial conditions and bankruptcy. So there are some problems can be summarized here. The first technical problem is the ocean waves are ever-changing and difficult to predict, such as sometimes too low or too high of sea level, wave height, wave length, wave speed, and so on. We spent a lot of time, money, and effort to develop controllers such as predict control, latching control, damping control, reactive control to optimize the efficiency. As research published in 2019, the author gave us results as this chart. Second technical problem is survivability in harsh conditions, such as heavy rain, strong wind, corrosion, storm. As of 2020, only 33 devices are still in operation, with total capacity is 2.3 MW. On the other hand, metadata on international marine energy projects show us 39 wave energy devices, with up to 62% have stopped working, 18% never deployed, 10% are planning, and only 10% are working. About economic problem, capital costs and levelized costs of energy are still very high at this table, although deployed on a large scale, up to hundreds or thousands of megawatts. Clearly, this result is influenced by the above technical problem. So, can we do it better? Here I have some solution for technical problems. Technical solution 1, polymechanical, no controller, with spiral springs. There are 3 kinds of spiral springs: the constant coil distance, the constant force, and the without coil distance is used in our system. It is commonly known as power spring, normally packaged in housing. The power spring can work up to 20 revolutions or even higher. And polymechanical colute, assembled from some parts at this picture, and the pendulum with self-adjusting length. Technical solution 2, main converter isolated from seawater and perfectly shielded. I will discuss more detail about this solution in the next slide. In terms of economic problem, because they are assembled from common materials, easy to find and easy to manufacture, estimated around $2,500 per kilowatt. It means 2,147 euro. The capex and opex will be competitive when investing and deploying on the scale of tens of kilowatts. It is fully price competitive by 2030 or even 2050. Now let's see how does it work. I will discuss more detail of technical solution here, and then a detail of working principle. For survivability in harsh conditions, the system is completely isolated from seawater to avoid corrosion, perfectly shielded by a cover box. The cover box is created by non-vertical and non-horizontal surface, which minimize the impact of heavy rain, vertical fog, and strong wind, horizontal fog. The only thing that sticks out of the box and comes into seawater is an anti-corrosion pendulum. For ocean waves are ever-changing problem. Despite the sea level change in shallow water waves, the pendulum with self-adjusting length can still oscillation under action of weight and gravity. If the pendulum length is not self-adjusting, the whole system can be placed on a flat structure, so that the pendulum is always semi-submerged in water. Or we can use two floating buoy version for deep waterways. Despite the seaway condition is fast or slow, less or more movement, the energy is stored in the spiral spring and then released by using a clutch. Now a working principle. The stopper keeps the spiral spring's potential energy always positive at the initial position, and the clutch in the lock state is ready for storage phase. Under action of weight and gravity, the pendulum oscillation and alternately one-up spiral spring on both sides. A one-way lock mechanism prevents the spiral spring from releasing potential energy if not accumulated enough revolution. Anytime the spiral spring reaches enough revolution, the clutch changes to release state, releasing the elastic potential that turns the gearbox to the right, the generator, and it back to the initial position. As you can see here, there are two trigger moments to exchange state. In the first state, an energy from the pendulum is used to compress a big spring inside the tube, but from uppercase L1 to uppercase L2 by forcing the ball screw to run withering. The withering lock the big spring and release small spring, and it changes to second state. In the second state, it depends a small energy from the spiral spring to lead the trigger ring back to the home position. At this, under second trigger moment, it releases the big spring, and the big spring forces the small spring from lowercase L1 to lowercase L2. Now, let's see a simple simulation of this clutch. And here is a gearbox, two input shaft with a one-way bearing chain gear and one-way output shaft. That's why it called it one-way gearbox. As detailed calculation in paper, step by step, by using basic formulas and laws, such as mechanical power, electrical power, spiral spring torque, translational kinetic energy, efficiency, law of gearing, gear ratio, speed, and torque. We got here summary parameter energy process of an ideal system. As the result, conversion efficiency on one side from the pendulum to alternator output is 61.79%. Okay, the article introduces a new method to extract oscillatory energy using pendulum spiral spring. In particular, spiral spring and clutch proposed to completely eliminating the controller and related device in compare with previous system. The system was totally shielded. The cover box was created by non-vertical and non-horizontal surface to minimize the impact of heavy rain and strong wind. Besides, the inclined surface also helps the water stream to condense and flow outside without affect the machine path and avoid corrosion. In addition, there is also a point mentioned in solution 1 that it is possible to use a float to lift the whole system instead of using a self-adjusting length pendulum, and the system with two having buoys for deep waterways will be studied further. If you are interested in this topic, more detail can be found in paper 148 of this conference. By the way, I would like to introduce a little bit about my working place. This is the new campus of Vietnamese German University, covering a total area of 50 hectares located in Bến Cát District, Bình Dương Province. About this presentation, if you have any question, please write in here or you can email us later. Thank you for your attention.
For question. Very interesting. I have question.
Hello. Thank you very much for your presentation. Have any question, Professor Zhu?
Yes, I have question. Let me ask some question.
Uh,
Hello, my friend from Bixio province. My name is.
Sorry, I will share screen again.
Yes.
Yeah.
Are you listening to me?
Yes, I'm listening.
Yeah. Okay. My name is Wu Zheng. I come from Sultan University in Da Nang.
Yes.
And very interesting presentation because it concerns the renewable energy, green environment. Very interesting. My first question. So your station, I say, should construct in offshore. I mean the distance from the cup, the sea cup. So how we can transmit the electro energy from the offshore station to the cup? The problem. Okay?
Yeah, I see your question.
Yes.
Because I already suggest some solution here, and with the version, let me see in the solution. Okay, here. Because I have three kind of version. The first is pendulum. It's only for the shallow water. And 2-point version either for offshore version, for offshore wave. In this article, only discuss more detail about the pendulum oscillation for shallow water. It means in the area of subzone. In the subzone, it means the movement in the translational is more effective than the vertical. And for the receive the energy from far away from quartz, I think it's possible to saving energy to the battery in the system and use some pillar of electric pillar side to lift the energy from the sea to the cost.
Okay. Understood. The next question. Yeah. We have renewable energy from the wind, from solar panel, and now very new method to accumulate the energy from the wave in the ocean. So comparison between three kinds of renewable energy, your opinion, how is advantage from the wave energy before two different?
Sorry, you mean the advantage of the wave energy compared to the wind and solar?
Yes. Explain, please.
Yes. I think as I mentioned it before, it 224 years. For very long time ago, the wave energy is still in the researching. It's in no any official commercial device. So until now, the way energy is, have the opportunity or the market and the opportunity to develop, and if it's successful on commercial, it will be the first advantage. And the way always day by day and night by night is on day and on night. It's not similar to the solar only in the day, and in the night is no solar power, and ocean way are always even in night or day. And the wind is, I think the wind is still not very stable as the ocean way. Yes, I think so.
Because in Vietnam, as we know, we concern this energy from the wind and from solar, but with the wave in the ocean, we have very lack of information. That's why my question. And do you think the future for the wave energy in Vietnam?
Yes, I just review some information in the previous research, and I see it why till very long time the wave energy is still not really commercial. So I think it based on the technology, because the technology affect to the economic problem, because many devices have been tested and decommissioning and improved and redeployed over the year, and it's really not return money, because in so many pay, but it work only 1 year or 4 years or 6 years, and it cost 10 of million of euros, as you can see here. For example, pyramid, so expensive and only work in 4 years, and the way dragon very expensive and work only 6 years, and it's not yet returned the money payback, and Seto is very expensive and working only 1 year. So I think the economic problem and the technical problem also affect the market of the ocean wave energy. So my research and idea is provide the solution. Maybe it help the future, the wave energy it will be adjust and used in the future.
Thank you. Thank you for your answer.
Thank you, Professor Dương Vũ, and thank you, the author Phạm Vũ Năng. Thank you very much.
Yes.
Okay.
So I can stop sharing here.
Yeah. Okay. Thank you very much.
Yes.
Okay. Okay. Thank you very much. Thank you for your attention.
We let's continue. We invite the author Nguyễn Văn Biển add on with the paper ID